Hello everyone, let us solve the second question from today's weekly contest, that is maximum prime difference. So in this question you're given an integer array nums and you have to return an integer that is the maximum distance between the indices of two prime numbers in nums, right? Alright, so let us first understand what is given in the question. So you're given the array and what you're told here is you have to tell what is the maximum distance between two prime numbers in nums, right? So you have to find prime numbers. So here I can see 2, 5 and 3, right? These are the prime numbers inside of nums. Now what I have to do is I have to return the maximum distance. Now the distance between 2 and 5, what is it? It's 2, right? The distance between 2 and 3, it's 3. The distance between 5 and 3, it's 1. So what you have to return? You have to return the maximum distance between the two indices, and which is 3, right? So 3 is going to be the answer in this case. Now what if there is no primes present? The answer is obviously going to be 0. And if let's say one prime is present, then also the answer is going to be 0. For example, in this test case, you can see you have nums as this and there's only one prime number here. So the distance between two prime numbers, so they have mentioned not necessarily different, right? So two prime numbers is going to be what? 2, right? 2 minus 2 basically, which is this index 0, 1, 2. So at 2 index, only 2 is present. So 2 minus 2, that is the maximum distance, which is actually 0. So now I hope the question is clear. Now let us see how we have to solve this question. So as you can see, what you have to do is simply, you have to find out the first occurrence traversing from the left of a prime number, and you have to find the last occurrence, right? Or the first occurrence while traversing from the right. So if you traverse from here, what is the first occurrence of a prime number? And if you traverse from here, what is the first occurrence of a prime number? So that is what we have to do. And as soon as we get that, right, first occurrence from here and first occurrence from here, I can simply subtract these indexes and find out the difference. That will be the maximum distance, right? It's pretty obvious that between 2 and 3 is going to be the maximum distance, not between 5 or 3. So you don't need to consider different combinations, etc. You can simply take the first occurrence from here, take the first occurrence from here, and return an answer. All right, so I hope that is clear. Now how are we going to achieve it? So the approach is pretty simple. First of all, I need to write a function to know whether a number I'm standing at is a prime number, right? So first I need that, right? So what I'll do is I'll start iterating in this. So here, instead of trying to approach from the right, what we're going to do is we're going to iterate only once in the array, right? And we are going to find out that we're going to take an index variable, right? Initially it's going to be -1, that we have not taken any value from here, right? Which is a prime number. Okay, so this index is going to represent the first occurrence from the left side of the array. Okay, so what we will do is we'll start iterating here. Let me clear this a bit. So I am at this particular index, right? So right now the index value is what? -1. Okay, I am seeing 4 and it is not a prime number, so I'll move ahead. I'll not touch index, right? Or I'll not do any calculation. We'll also take a variable called mx. Let me write it here. So it's going to represent the maximum distance. All right. Okay. So mx will initially be 0. Now we'll come to 2. So I can now see that 2 is a prime number. So what we will do is we will check if index is not -1. That means a prime number has been encountered before, right? But index is -1. That means no prime number has been encountered. So we cannot obviously calculate the maximum distance, right? So what we will do is we will simply replace it with the index, because we have found a prime number here, right? So we'll replace it with a 0, right? But we will not do any calculation. We'll not calculate the maximum distance. Now moving ahead, we'll come to 9. So 9 is also not a prime number, so we'll keep moving. So 5 is a prime number. So now what I will do is I will check IDX again. So IDX is now 0 and not -1, which means I have encountered a prime number before. So now I can calculate a distance, right? So what is the distance? Distance is going to be, this is the 1th index. Oh, sorry, IDX is going to be 1 here. All right, so this is the 1th index and this is the 3rd index. So what is the distance between them? 3 minus 1. So basically I minus IDX, right? So this we will include in our mx variable because it is greater than the mx value 0. So we'll be taking the maximum, right, of the previous mx and the current I minus IDX value. So here in the mx we will take 2, right? Okay, moving further, my I will be at this position. Now this is the fourth index. Again, I can see my IDX is what, 1, which means I have encountered a prime number before. So now in my IDX, I will not update it. I will not repeatedly update it. I will only update it when it is -1, right? So that I get the first occurrence from the left side. That is what matters to us, right? So now I have the IDX is 1, which means a prime number has already encountered before, and I am again standing at a prime number. So I'll again calculate the I minus IDX value and store it inside of my MX, right? So maximum of MX comma I minus IDX. So right now it's going to be 4 minus 1, which is 3, right? So now MX will get updated to 3, and now I have completed all the iterations and I can simply quit out of the loop. Now you can see I've got MX as 3, which has to be the answer as well. So that is it. That is what we have to do in this question, right? Now, as for calculating the prime, so we know an algorithm that helps us to calculate prime in square root of n time, right? Big O of square root of n, right? So let us go to the code and quickly see this. So yes, the code, right? So here you're calculating the prime, right? And so how are you doing it? First of all, if you're passing an n here, right, and this is a boolean function, so it's only going to tell us that if whether this number n is a prime or not. So if n is less than equal to 1, then definitely it's not a prime. Then we will be iterating here up to square root of n, right? And we will be calculating, we will be simply seeing n modulo I. So for prime numbers, we know the property, it's only divisible by itself and 1, right? And no other number. So if a number is divisible by some other number, that means we have to return false. It's not a prime. Otherwise, we can return true. Now, why the square root n logic works? It's because when we do x into y, right? So x, right, one of the numbers is always less than square root of n, right? So they appear in pairs. They appear in pairs. So if I have already checked for this, right? See, n could be a multiple of this. So I have already checked for this. I don't need to go and explicitly check for this number, right? So this is why this algorithm works in square root of n time. Now let us move on to the main function and let us see how we are how we are coding the approach we just discussed, right? So now we know how we are calculating prime. Now let's come here. So mx variable is going to store the maximum distance, which is initially 0, and idx is initially -1. So it's the it represents the first occurrence of a prime number in this nums vector. Alright, so now we'll start iterating from I is equal to 0, right? And we're going to only do one pass here, okay? And we're going to check if the current number I'm standing at, if it is a prime. So I'll simply call this function on this, and if this is a prime, then I will check, have I encountered a number before, right? So that means idx will not be -1, right? We already saw when we did the dry run. So if idx is not 1, then I can get the answer, right? But if idx was 1, right, was -1, then I have to update it to I, because the current number I'm standing at is a prime number and we had not encountered any prime number before. So I have to update the idx to I. This is the first occurrence that I'm getting, all right? So this is what we are doing. We are only calculating the answer when we have already encountered a prime number. So then we can simply see if after completing these iterations, right, I can check whether idx is still -1. If it is -1, then definitely there was only one number, right? And for example, in this second test case, what we had to return was a 0. That is its index minus its index, which is essentially 0 only. So this we will definitely get here. So we have to return 0. Otherwise, we can simply return maximum distance, right, which we have calculated here. So I hope now the solution is clear. How we're implementing it is also clear. Now let us see the time complexity and space complexity for this solution. So the time complexity is going to be n into square root of n. All right, so why is it coming? Because for each and every number, we are checking whether it is a prime or not. And to check whether a number is prime or not, we are consuming square root of n time. So n into square root of n is going to be the time complexity. And for the space complexity, we are not using any extra space. So it's definitely going to be constant. So I hope now the solution is clear, and that's it for the video.